Okay, I'm going to do a quick walkthrough of two of the problems in this, and that's hopefully going to set you up for the next section. So, I'm looking specifically at 961, and I'm totally ignoring this no calculator piece here. In a perfect world, we'd take some time, we'd graph it by hand, we'd review some of those strategies, but I'm going to cut right to the chase. I encourage you to follow along because we're going to use some technology if you are able to do so, or to try it on your own because you do want to be equipped in that skill. So, they asked us to consider two following functions: f of x equals x squared minus 2x minus 8, and g of x equals negative 2.5x minus 3. We need to graph these on the same set of axes, and then we're going to interpret how many times the graphs intersect, and we're going to estimate those points of intersection. Okay? So, let's take a look at this one right here. I'm going to start off by showcasing our graphing calculator for a moment. Okay, so let me zoom out just a little bit. Okay, joys of technology. So let's dive right into this problem right here. Starting off, I'm going to go to my y equals button, and you'll notice that as a result, I get these screens right here. Let's see if I can make sure we can see this. That's what happens when you make do right at the end. I'll just hold it like this. Okay, so we've got this right here. I'm going to go ahead and delete that because we don't need that. That's a past one. Okay, so here's what we're going to do. We're going to type in that first equation. This is my variable key right here. Depending on the set, it'll display different letters. So I've got x squared minus 2x minus 8. And then for my second equation, I've got negative 2.5x minus 3. Notice that the negative sign is not the same as subtraction. Now when I go to graph this, I'm going to make sure my window's in the right spot. So after pressing on zoom, I'm going to come down here to Z standard, which is the sixth one, and it basically is going to graph me at a standard 10 by 10 graph. Okay, so we do that and we get the following picture. Now hopefully you saw before the bottom piece came in that our graph intersected in two spots. We've got one right here and another down here, and so we have two clear intersection points. Now, suppose we want to find these using technology rather than algebraically. Our focus today is going to be algebraically, but I think it's worth it to showcase the skill on a calculator. So what are we going to do? If you go to right here in blue, it says calc. In order to get the blue feature, I have to press second first, so second calc. And if you scroll down, number 5 says intersect. Okay, so I'm going to select intersect. When I do so, I get this little bouncing cursor that's down here on the y-axis. And if I move, I can move it left and right using the arrows. And you'll notice it says first curve. Here's the way it works. On whatever curve you're on, you need to be to the left of the intersection point. Okay, so see how my cursor here is to the left of my intersection point. I'm going to click enter. Now all of a sudden it jumps to the other curve. In this case the line, and it says second curve. So what I'm going to do is I'm now going to move so I'm to the right of that intersection point. So notice my cursor is now clearly to the right of where my two curves cross. Hit enter. The calculator has some fun and it asks you, do you want to guess? Well, of course I want to guess. And it does some math and it spits out that the intersection point that I just isolated is at negative 2.5 comma 3.25, and we can read the x and y off the screen. This is a great way for you to check your work. Desmos is another option. We can estimate those from the graph. The challenge though is what happens whenever it's not as easy and we need to use some other strategies, and we'll highlight that in just a bit.